Hello, all you math Padawans out there. Today, we are going to be looking at a review for rate, ratio, and proportions. Are you ready? Lightsabers, ignite! Zoom. Here we go. Okay, all you math Padawans out there, you want to do well on a test that's coming up that we are focusing on rate, ratio, and proportions. And how are we going to do that? Well, the important thing, of course, is to have a growth mindset and make sure that you're just improving from where you are currently, or you've at least shown where you've been in the past. So, one thing I always find is that, like, if there's a kid and they're like, I wanna jump. I'm currently jumping. I can jump over this box, right? I'm like, yay, I can do that pretty well, and that sort of thing. Well, that's great, and that kind of stuff. And there's two other boxes, right? There's this box, and then there's this box. And a lot of kids want to go straight to jumping over this box. Well, is that realistic? It's not. It's not realistic. What's more likely is that you work a little bit and you jump over this higher box, and then you put in some more effort and some more work, and you keep practicing a little bit, but you want to set reasonable goals. So make sure wherever you are in your math journey that you're setting up reasonable goals and that sort of thing. So here we go. If we're talking about ratios, proportions, and all that kind of fun stuff, let's just get into, I'm probably going to focus on common kid mistakes, but one thing for ratios, so ratio top tips. So these are ratio top tips. I'll tell you from a perspective of a math teacher, where do kids go wrong? They forget what a ratio is. Forget it's dividing. Okay, so number one, remember that ratios, it's basically division. Okay, so when you have things like it says 15 to 3, just remember the little dots. What do you call those in English? You call them like what? Colons? What that really means is 15 divided by 3. And we can all do that. We can all do 15 divided by 3. So that gives you a 5 answer, which is really 5 to 1. Because don't forget that a whole number is always over 1. So division all kind of goes together, right? So that's what you're doing there. So that's the first thing. It's just dividing. The second one, and why do we not back to yellow? Why is it not back to yellow? That's weird. Try this again. Number 2. There we go. When you have mixed numbers, so let's say you had, I don't know, 7 and, what's a popular one? 7 3/4 in comparison to 9.5? Sure. So a couple things for these ones. You always want to convert first. So step 1. So for these ones, these are kind of messy, right? So you have to always convert to improper and then divide. Convert to improper, then divide. And I'm just going to give you, this is how I teach my students. And it seems to go pretty well if they do their work. That's always the trick, isn't it? So I'm going to go and convert this. And that's going to get you 31 over 4. Remember, this is a dividing question. So again, it comes out that top tip number 1, right? It's just dividing. There's my dividing sign. What does 9.5 become? It comes out 19 over 2. So I love that saying of keep, change, flip. So I keep the 31 over 4. So I keep the 31 over 4. I change the dividing to multiplying, and I flip my other fraction, so it's 2 over 19. Now I go and do my cross reducing because I have been told that's really helpful, and it's going to be super helpful. 31 times 1, so now when I multiply, I go across the top, and I go across the bottom, so I'm multiplying across the top, so it's just 31, and I multiply across the bottom, that's going to be 38, I think. And that is the final answer. Your teacher might want you to write it as 31 to 38. Done. Okay, so those are some big issues I kind of see pop up for ratio things. How about proportion stuff? So my proportion top tips. So proportion top tips. And this is really going to work with multiplying a little bit and dividing, of course. So first off, let's just take a look at the idea of cross-multiplying. So the one big idea you always want to kind of remember is cross-multiplying. Keep that in mind. So I'm going to give you the example. Let's just say we had, I don't know, 9 over 8 is proportional to, let's say, 10 over x plus 2. So we're going to go and cross-multiply this little equation. So when we're doing that, I'm going to show you where kids go wrong. Just like that. I'm going to show you a little bit slowly. So I'm going to say 9. This is 9 times x plus 2. And this is 8 times 10. I'll show you this as just showing it like that. Sometimes I'll just kind of cheat a little bit and we're down 80 because we know that. But then I'm like, how did that become 80? Well, I multiplied 8 times 10. But anyways, here you go. If you're going to go wrong, if you're a kid in my class, you know I always draw these little arrows to show you that you're multiplying by that. You're going to forget multiplying by that positive 2. So please don't forget that. Please, please, please. So this is 9x plus 18. It's going to be equal to 80. And then you just go and you follow the algebra laws, right? So if you need some help on that stuff, go check out some older videos. Go to Khan Academy, get some practice in there. This has got to be pretty good for you. So I'm not going to spend too much time. I'm just going to kind of go through it, and kind of go from there. What's that? 72? Is that 72? No, it's 62, right? 62, and then divide both sides by 9. So your answer is 62 over 9. Don't write down decimals or weird mixed numbers, okay? That's just, yuck. Yuck. Don't do those. Improper fractions are the way to go. So you got that kind of stuff. The other thing I want to talk about a little bit is unit rates. So unit rates are awesome. So unit rates, let's think of an example. Let's go with 2 candy stores. Okay, so you got candy store A, and you got candy store B. Candy store B. And what kind of candy are we selling today? Well, we are going to sell some candy canes. Why not? Candy canes are fun and happy, right? So we're selling candy canes. Cool. We love our candy canes. Store B, it sells, what does it do? It does 19 candy canes, and it does it for $98. So 19 candy canes for $98.80. It's a great deal. And Store B, what does Store B do? Store B is just getting going in the candy cane business, and it does 7 candy canes for $34.30. If you're a kid and you want to go and buy 1 candy cane, just 1 candy cane, what store should you go to? So we're finding out unit rate. So unit rate, remember unit rate, it just means for 1. That's it, just for 1. So 1 candy cane. I want to know what it's going to be. So in order to do that, I would just do this. So for $34.30, I get 7 candy canes. I want to know how much for 1 candy cane. So here's the big thing, right? When you're doing these kinds of things, the same things are on top. This is the money, and these are the candy canes. So the same things are on the top, same things are on the bottom. I'm going to show you this one and do it a little bit differently. I'm going to show you in this one 19 candy canes compared to 1 candy cane. For 19 candy canes, it took $98.80. And I want to know how much this one is. So for this one, notice I put the scenarios on top. This was scenario B, and this is scenario kind of for 1, I'll call this A sort of thing. So you can set up your proportions always a little bit differently, as long as you're keeping the same consistent things on top and the same consistent things on the bottom. In the end, for this one, this is the math. I'll do the math in green, I guess. So the math in this one just says 7x equals 3430. And I think x is 5.2. Oh no, it's not 5.2, it's 4.9. Sorry. Is it 4.9? I think it is. I just did this, I should know. Yeah, it's 4.9. Oops, there we go. Let's go, where's my backwards button? There you go, it's 4.9. Over here, you get 19x is equal to 9880. And this one is going to be 5.2 per candy cane, right? That's what we're talking about. So we're going to go and buy your store, your candy canes. You're going to go obviously with this one right here, okay, and get that price. So there you go. So using unit rates, pretty interesting. So once you have that unit rate, then you can go and say lots of different things. You could go and say how much 1,000 candy canes would take. So if you had to do this by 1,000, how much would it take? So you can, once you have unit rate, you can really start to go and solve a lot of things. Okay, moving along. Let's talk about slope. Oh yeah. Slope, it means rate. It means rise over run. Sometimes you use a funny letter called M. Okay? There's lots of different ways to do this one. You have a formula and you have counting. You can count. You can count between points on a graph. Between points on a graph. So you can do that. You can use a formula. It's the change in y over the change in x. Okay, so lots of different ways to do this. I'm going to show you a couple of different things. Here we go. I'm going to do a 4x4 grid. 2, 3, 4. And I'll use the same question for multiple ways of doing things. I should be able to use a straight line somehow. What's this tool? Whoa! Look what I just got. This is awesome. If I can move this, is going to be even... Oh, if I can change the color, this is going to be awesome. This is what not to do when you're making a video. Well, I want this to be red. Oh, how could I move this? Maybe this thing? Nope. But you know what? I'm just going to go with it. Okay. So imagine... This works out pretty well, actually. Okay. What does this do? Oh, that's pretty good. If I click on this, what is that going to do? Where did this go? Okay. I'm happy with that? Yes. Okay, I'm going to get rid of this. Oh no, come back. Where did this go? How do I select that? This has turned into a... This is not turning out well. I want this line to go over there. Come on. How hard is this to do? Sound like Luke Skywalker complaining. Okay, well, this I wanted a different color. Good. I'm excited by that. Can I do this? Nope. Can't do that. Oh, should I click the X? Yeah. There we go. Sweet. We knew we could figure it out, right? We did. Let me erase this one. Okay, so here's my line. I want to figure out the slope. If you get something like this, you're looking at it, and you're like, I don't know, where do I start? So you can count between the points on a graph, but a couple of things that students always say, but there's no points here. You're right, there isn't. You got to go and find 2 good points to use. So where would they be? You want to find ones that cross very, very clearly the different lines of the graph. So this one, I would say this is a very clear point, and this is a very clear point. Okay, so those are the ones that I would be using. This one is called 0, 3. That's the coordinate. And this one is called 1, 2, 3, 4. It says negative 4, 0. Okay, so first off, find really good points. Then go and label them. I'm going to call this my x1. I'm going to call this my y1. Those are my first points. Now, it doesn't matter which ones you make the first points. It really, really doesn't. Okay, I can prove in other videos, but just say these are my second points. Cool. So now I'm just going to go and let's do the counting. So that's the easiest way to do it. So let's just count. Rise over run between 2 points. I'm going to go this way first. I'm going to go for this one. I'm going to rise 3, and I'm going to run 4. 3, 4. So it's rise over run. So I rose 3 and I ran 4. Some students like to go backwards. That's fine. Let's do this. Let's go backwards 4. Go backwards 4, right? That's negative 4. Let's go down. When you go down, it's negative 3. So the rise was negative 3, and the run was negative 4. But remember, a negative over a negative is still positive. So it doesn't matter which way you go. Let's go and use the formula. So it was y2 minus y1. So that's 0 minus 3 over negative 4 minus 0. So again, we're going to get you're going to get this double negative happen right now, right? Negative 3 over negative 4, which is just 3/4. Guess what happens? How do kids go wrong in this question? The only way to go wrong in this question is that you put the x's on top. That's the only way to ever go and get this one wrong. Okay, so just be careful. Y's go on top, x's go on the bottom. Okay. What other kind of things? Oh, let's do the tricky one. There's always the tricky ones. Teachers love this line. They say, what's the slope? They love this line. This is what I do if I was a kid. There's only 2 options for these ones. It's either going to be slope is 0 or slope is undefined. Those are your only 2 options. If you get confused, this is what you do on a test. You draw 2 dots on the line. You find out what those are. So this would be 4, this would be 4, 2, and this would be 4, I don't know, whatever, negative 1. So you can do 2 dots, and you can do the formula. So if I did the formula on this one, so y2 minus y1, so that's going to be like, what's that going to be? Negative 3, and then over 0. That's what it's going to be. And is that what it's going to be? I think so, right? Isn't it? 4, 2. So 2, yeah, 3. Yeah. So when I do this one on my calculator, you're going to get error, which means undefined. Most teachers like UD. If you have a different line that looks like this, let's say you have a line like this. Again, draw 2 dots. There's a dot, there's a dot. So this would be 1, negative 3. And this would be 0, negative 3. So for this one, you would get 0 over 1. And when you do this one on a calculator, you're going to get 0. So your slope is 0 for that one. So make sure you know the straight lines, the vertical and the horizontal, of how that works, because that's really important. Other things that you need to know about. If something is proportional. You probably have heard your teacher talk about this. Is something proportional? Well, 2 things. It has to go through the origin, which is 0, 0. And it has to have the same rate. And so that's what you need to kind of be looking at. So when you have stuff like this, say you had this nice straight line, is it going through the origin? Is it going through this point? No, so it's not. You need things to be going through the origin. Let's make this a color that we haven't used. There we go. Just imagine I drew straight. So yes. Typically you're going to get tables. All right, you can get some kind of a table. Wow, this is not a pretty table. Okay, so you have X's and you have Y's, and you're gonna have something that maybe shows, like, I don't know, it's a good example. Let's say this was 20 and this was 24, and you got like, I don't know, 22 and this is 30. This is 24. And this is 36. Okay, so you're looking at this and going like, okay. These are going up by 2. That's exciting. And these are going up by 6. Oh, therefore it's going to be proportional. Well, is it? Is it? I don't know. Let's just see what happens. Right, because a lot of kids look at that and go like, oh, that's totally is. But you got to jump all the way back until eventually you get to 0, 0. Does it get back to 0, 0? Let's just keep going in that pattern. This has to go back 10 times to get to 0. This has to go back 4 times. It's never going to do this. It's never. So it's not going to be proportional. Another way to do it is this. You could do kind of 20 over 24 is that the same as 22 over 30? And you can see what happens when you cross multiply. You could also see this. So you could do 20 times 30 and you times 600. Does that equal, what does that become? 528. Right? So no, it does not. So you can always cross multiply like this as well. So it's not. It is linear though. It is a straight line, but it's not going to be proportional. So be very, very careful about that. Okay. Let's get on to scale drawings. So the last thing we're going to look at. And this is the massive review. Typically all these topics, all these topics usually go together, right? Scale. And I'm also going to throw in some similar stuff as well. So here, let's do similarity first. All right, let's do similarity first, because similarity is going to be nice and easy. So if something is similar, what are the two properties? They have the same shape. So if something's similar, it's the same shape, and things are proportional. It's not the same size necessarily, not the same size. So your classic example is going to be a triangle. It's going to be like, here's your little triangle, and here's a bigger triangle. And I'm telling you that they are similar. There's that little cool symbol. And you basically have numbers that you're going to go and create proportions. So let's say you had, this was 2, this was 5, and this was 10, and this was 25. Okay, so you have to go and compare that. So there's different ways to compare. You can compare 2 to 10 is the same as 5 to 25. You could compare it that way. You could also compare it this way. The little triangle is 2 to 5, and the big triangle is 10 to 25. There's two different ways. Everything still works the same though. Look what's cross multiplying. The 5 and the 10 cross multiply. Oh look, the 5 and the 10 cross multiply. So just to realize that you are cross multiplying and seeing how that works. So if you go and you cross multiply, everything should be equal. So you're going to see that 50 is equal to 50. Okay, and if I asked you what's the scale, here's the important part. I'm going to call this A, I'm going to call this B. If I asked you what's the scale of A to B, how would you figure that out? So A to B is 2 to 10. 2 to 10, which I simplified to be 1 to 5. How do kids go wrong? They get the order wrong. Sometimes math teachers are tricky. They'll say, what's the scale of B to A? So that would be 5 to 1. So the order matters. Don't forget, order matters. Cool, got it? Sweet. Now, going and figuring out some scale things. So scale, I love scale questions. They're kind of fun. What are some good top tips? Number one, make sure you have the correct units. So correct units. Remember, I'm going to go like this. I'm going to say scale can have different units. So we can have 2 units. Example, like kilometers per hour. Those are two different types. But if you are asked for scale factor, it has to have the same units, which means you often have to convert. Example, centimeters to meters. So you have to do some converting sometimes for those kinds of things. So be very, very, very careful with that. Get rid of that. Get a new one. Here we go. So let's get to it, shall we? So scale factor. Oh, what should we have? Oh, what's a good one? Oh, lightsabers, or why not? Lightsabers. So lightsabers, basically we're doing a brand new yellow lightsaber. Go figure. Or a gold lightsaber. And because we're making a gold lightsaber, let's see, I need some browns. Oh, I'm bringing in the colors, the magic behind the colors. Right? Didn't Rey's like hilt? It was like her original staff, wasn't it? I think she had a really cool switch, right? Anyways, so let's just say we're doing our lightsabers, and we have our scale model, right? Because you're a factory, so you got to go and do a little scale model, and you want to produce the regular ones, right? There we go. There you go. Okay. We're all good. Goodbye, colors. There they go. And what are we saying here? We're saying that this little scale one, it was 5 centimeters. And the actual one was 1 meter and 20 centimeters. So like 1.2 meters, like 1.2 meters. Okay? And I want to know what's the scale factor. That's what I want to know. So for scale, this would be 5 cm is to 1.2 meters. Sometimes we'll want to actually say 50 centimeters is to 12 meters. Now, what did I just do there? Do you have any idea what I just did? What did I just do? Well, I moved this decimal over here. And there's a decimal right here. And I moved this one over to get nice whole numbers. Now, I had whole numbers, and now I'm going to go and divide these whole numbers by 2. So I would say 25 centimeters, oops, there we go, is to 6 meters. Now, it depends on your teacher. Some teachers like things to be in whole numbers. Some teachers don't. It really does depend. So that is very, very nice. Notice that I have centimeters and meters, 2 different times of units. So we're talking about scale factor. I got to go and change that. So here, if I had 5 centimeters is 1.2 meters. I need to convert this all to centimeters. Now, these are nice, easy numbers. So I'm going to go and convert. You always want to convert the bigger unit to the smaller unit. Okay, that's really important. So you want to do that. So I'm going to convert this, and hopefully you can see that's 120 centimeters. I times it by 100. You should know centimeters to meters. That's times things by 100. That should be pretty easy. But here, now you have to go and divide this by 5. So divide this by 5. And you'd have 1 centimeter. We're not done yet. 1 centimeter to, what's that going to be, 24? 1 centimeter, 24 centimeters. Now the cool thing when it's in the same unit, this is what you can do. This is why we use it. So we can go and cancel out our units. And now your actual scale factor is 1 to 24. So that's your final answer, 1 to 24. If you're going from the model to the real life, like that. So that's really important. I'm going to give you one top tip. And it has to do with when you're dealing with area. If area, you're doing questions with area, you need to square the scale. So usually teachers will give you something about a square or a rectangle. They give you something like this anyways. They're going to give you something like this. So I want to show this. This is the last thing I'm going to show you guys. So let's say you had this. This is square A, or this is rectangle. Rectangle, square, back rectangle. Say it's a 4x3. Super simple. 4x3. And I'm going to ask you. How should I say this? I'm going to ask you what's the perimeter and what's the area. Okay, so this would be pretty simple, right? So area, you just multiply them together. It's going to be 12 units squared. And the perimeter, what's that going to be? So 14 units, right? 14 units. Sweet. But then I'm going to say I want to go and, I don't know, triple. I want to triple the width and the length. So I want to triple the width and the length. So if I just had a bigger rectangle now, bigger, right? And I tripled the width and the length. If I tripled it, what would this become? This would become a 9. And I tripled this to become a 12, wouldn't it? Yes, I tripled. So what am I doing? I'm timesing it by 3. Sweet. So what's the new perimeter? What's my new perimeter going to be? Anybody? Am I hearing you guys yelling at your screens right now? I hope so. I hope you're all saying, well, if I tripled it, it's just going to be 42. Yay, 42. 42 units, right? Sweet. So what was the relationship between the 42 and the 14, right? What was it? You just times it by 3, didn't you? Yeah, for sure. Sweet. So kids get super excited. Oh, what's the area then? I'm going to times it by 3. So it's 36. Yeah. No, it's not. It's not. It's 108. It's 108. Wait a second. It was 12, and then it became 108. How did that happen? Well, because if you're doing area, I needed to square it. So it's not times 3, it's actually times 3 squared, which is timesing it by 9. 9 times 12, the original, is 108. So please, please, please be careful when you're doing area questions and scale, because you need to square the scale. And I cannot say that enough for those sorts of things. Maybe we'll do one more bonus. Should I do a bonus? Sure, I'll do one bonus one. Should I do a bonus one? You know what? This has been a really long video. 33 minutes. That's insane. I think you're pretty good for rate, ratio, and proportions. I think you're going to be good. Do I want to do one more? I kind of want to do one more. Can I do one more? Okay. I'm going to do one more. I just want to show you with kind of drawing stuff. Maybe I'll just show you the example. So like, I want to show you shadow questions, because shadow questions often pop up. And here's a shadow question. So so here's your Jedi Knight, flowing cape. So there's your Jedi Knight. And does anybody have a? Let's just stick with the yellow lightsaber. There we go. And maybe it has like a purple hilt because I'm being lazy. There you go. Anyways, and you have a sunshine. How's this gonna work? Is this gonna work out well? I hope so. You have a sunshine, and it's gonna leave a shadow, like this. So usually these kinds of questions kind of go like this. So they say this person is 2 meters tall. It's a giant, and their shadow is, I don't know, 5 meters. Well, let's say there was a little droid. There's a little droid. This is a horrible droid. Whatever. There is a droid, and the droid obviously has a shadow. The droid is 80 centimeters. What kind of shadow does the droid have? So you have two things going on here. One, you have this 2 meters by 5 meters. And the other one, you have this little 80 centimeters. I'm going to keep this in meters, so 0.8 meters, and then you have to figure this out. So I just wanted to kind of show how shadow stuff works, because oftentimes you're creating this proportion. So you have, again, how you want to be doing it, but 2 to 5 is the same as 0.8 to x. So then you want to just go and cross multiply and solve. So you can go and figure out that. So that's your shadow questions. The other questions are always going to be shapes within shapes. Typically you have triangles. So again, a lot of triangle stuff here. So here's your triangle. And this is what I kind of always see all the time. You're going to get an X somewhere. I don't know where. Maybe this is X. Maybe this is 3. This is 2. And this is 10. Okay. A couple things. Last top tip is you want to draw both. So number 1, draw. There you go. So you want to draw both. Super important. So what I mean by that is you have a little triangle. See the little one there? It's a 2 by 3. 2 by 3, super small. And then you have a bigger triangle. And here you have to add these together. So this bottom is x plus 3 now. Oof. And this is 10. We go back to the shadow kind of idea. So now you need to put that all together. So this would be 10 over x plus 3. I just compared those. It's going to be equal to 2 over 3. This goes back to one of the original questions we did in the very beginning of the video, where you have to go and cross multiply and do some really cool math. And that kind of stuff. So you're cross multiplying and solving. So when you have shapes within shapes, this is a small triangle within a big triangle, you really, really, really do want to draw both. All right, are you set for your tests? Yeah, are you going to go rock it? For sure. Growth mindset. Kick butt. May the force be with you. Have a good day. I hope you enjoyed the review lesson. May the force be with you. Work hard. Have a growth mindset. And always choose the dark side.